Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at completing the square. By the end of this lesson, you should be able to complete the square for quadratics with leading coefficient of 1, and also complete the square when the leading coefficient is not equal to 1. You'll be able to use the completion of square to find the vertex of a parabola. You'll be able to solve quadratic equations by completing the square, and finally, you'll be able to derive the quadratic formula by completing the square on the general form ax squared plus bx plus c. As the lesson proceeds, you would take note that I'll be using these terms. I advise you pause the lesson at this point and quickly take a glance through these terms before we continue. Without much ado, let's quickly look into the lesson. So let's start by looking at how to complete the square when the leading coefficient is equal to 1. When we say the leading coefficient is equal to 1, you know how a quadratic formula or a quadratic function looks like. A quadratic function is simply of the form we have y equals, so ax squared plus bx and then plus c. Now, if you are saying the leading coefficient, which is a, is equal to 1, that is, if our a is equal to 1, then we have our function being y equals, so a is 1, hence we have x squared plus bx and then plus c. This is our function. Now, if the coefficient is 1 and we want to complete the square, what you do is you take half of b. Whatever you have here as your b, take half of it. Taking half of it simply means we take our b and multiply it by what? 1 over 2. If you multiply b by 1 over 2, what do you get? You have a b over 2. Now, this answer that you have over here, that is the b over 2, we square it. You see, so our next step is to square whatever we have. If you are squaring, that is b over 2, we know from our laws of indices that the square is going to affect both the numerator and the denominator. So we can rewrite this as what? B squared over 2 squared, which is the same as b squared over 4. Any of them is okay. Now, after squaring this, what we do is our original function we have over here, let's write it in 2 parts. By 2 parts, I mean we are talking of the sense a is 1. So I mean, instead of y equals x squared plus bx and then plus c, we are rewriting it as y equals x squared plus bx. Then we leave a space and then we have our plus c over here. Now, with this space we have here, what we are going to do is we want to add and subtract this. You see, either this in this form or this in this form or this in this form. We are adding and subtracting it anywhere. So what we mean by that is let's take this form. This form is easy to work with. So you are going to add and subtract. So I'm going to say plus b over 2a, b over 2 squared. So we have added it. Then we are subtracting it as well. So b over 2. Here's what we have. So in actual sense, you know, if you have, let's say, m plus, if you have any variable, let's say m, and then you add and subtract it to a particular equation, it is still 0. You have done nothing. You get it? So we took the b over 2 all squared from nowhere, and then we are just adding and subtracting it. They would cancel out to give us 0, which gives us the initial function. But we don't do the cancellation, but rather we use factorization to simplify. Now, you realize that if you take this 3 terms That is the first three terms we have over here. They are actually the expansion of one particular binomial. Do you get it? They are an expansion of one particular binomial. That binomial is simply x plus b over 2. You see, if we expand this binomial squared, it is going to give us this. In a bit, we will look at it. So we have our y being equal to what? X plus b squared. What do you have in the bracket? That simply means you omit the second term. Take only the x, leave this one, and then whatever you have in the bracket, you bring all together to form x plus b over 2 all squared. Then we can choose to simplify this we have here. So simplifying it, we simply have negative a b squared all over 2 squared will give us what? 4. Then plus c, you see, which we can rewrite as what? Plus c minus b squared all over 4. Very simple, isn't it? Okay, so let's go to how this actually gives us these three terms we have over here. What we have is x plus b over 2 all squared. All right. So using our binomial theorem, we can easily expand this. So we have x squared, that is x squared, then plus 2 times x times b over 2. So that is 2 times x times b over 2. Then we have the last term, which is b over 2 squared. So plus b over 2 all squared. If you have to simplify, we have our x squared. And for this particular term, this 2 takes out this 2. And I'm left with bx. So plus bx. And then plus b over 2 all squared. This is what we had over here. You see. And then we got it by expanding this one. And that is just it over here. So this is the logic behind why we want to factorize all these three terms to give us just this. When it comes to completing of squares with a coefficient being 1, this is the method we use. When the coefficient is not 1, the method we use is just a build-up of this one. Okay, so let's look at how to work our completing of squares when the coefficient is not 1. So when our coefficient of x squared is not 1, that is to say, if we have y is equal to ax squared, then plus bx plus c, this a is not 1. Now take note, how you solve it depends on what you want to achieve. Do you actually want to factorize, or you want to solve for the values of x, or you want to look for your maximum and minimum value, or you want to look for the center or vertex of the quadratic function? So as we solve our examples, you know when to use which path. Now the path I'm talking about is, there's a method where you choose to divide every term by a. If you are dividing everything by a, we do it especially if our y is equal to 0. So if the y is equal to 0 and you divide everything by a, you are going to get 0 is equal to an x squared plus b over a x, then plus c. You see, this is usually done when our y is 0. But let's follow the standard procedure, which would even work for all scenarios. The first thing you want to do is to factorize your a from the first two terms. You see, so our function is giving us ax squared plus bx and then plus c. You see, So let's factorize this a out. If you are factorizing this a out, we have our a. A times what gives us x squared. A times what value gives us x squared. So if you have factorized a out, we ask ourselves a times what gives us ax squared. If you don't know it off head, you can simply say ax squared divided by a. This a cancels out this a and we'll be left with what? X squared. So it simply means a times x squared gives us ax squared. Then a times what gives us bx. So just as we did for this, we are going to take our bx and divide it by a. In this case, there is nothing to divide. You see, there is nothing to cancel out. So it is simply b over ax. You do that just for the two terms, and then we have plus c. This we have over here, you realize that if you want to test if what you've done is true, that is, if you want to revert the whole process, a times x squared gives us what? Ax squared. And a times b over a, the a cancels out this a to give us what? A positive bx. And we have our plus c. Very simple, isn't it? But we don't want to reverse, else why do we even do this? So now that we've been able to get our a out, we have factorized the a out, you are going to focus on what you have in here. Now, you take half the coefficient of what? X. Half the coefficient of x. The coefficient of x is b over a. So if you are taking half of it, it simply means you are multiplying it by 1 over 2. If you multiply this by 1 over 2, we have b over 2a. Now, if we take this, we now square it. Whatever you have here, you square it. So it simply means, let's take our b over 2a, and then we square it this way. If you are able to square it, now you come back to your bracket here, and then you add and subtract this square inside. You are doing everything inside the parenthesis. So what we mean is, we have our a, then into bracket, this we have here, which was x squared plus b over ax. You see, so we want to add and subtract the squared we have. We have plus b over 2a, that is squared, then minus b over 2a, that is also squared. We are done with what we have in the bracket, you see, then plus c. We have not changed anything because we have added and subtracted the same thing. They can easily go up to give us what we have here once again. So with this, you remember from our previous proof that these three terms here, that is these three terms, they can be factorized. Factorizing them gives us, so we have our a, then into bracket x plus b over 2a, all squared, that is these three terms. Then we have minus, so for now we can simplify this, minus b squared all over what? You know the squared affects both the numerator and then the denominator. So b squared over 4a squared. We close our bracket and then plus c. So with this that we've done, we want to now distribute our a over these two terms. So take note, if we have a into bracket b plus or minus c, and we want to distribute, a multiplies b, and then multiplies the c, so that we have a b then plus or minus a c. You see, that is what we want to do over here. So for this term we have what we want to do is this A should multiply this first bracket, and then it should also multiply this first bracket, and then it should also multiply this second term. That is the two terms we have there. So A multiplies this to give us A into bracket x plus b over 2a all squared, and then A times all of this over here also gives us a negative, so a b squared all over 4a. So we have opened the bracket. We can easily write the plus c. This can be kept as it is. So we have our a into bracket x plus b over 2a all squared. Then simplifying this, you see there is an a here that can take out one of the a's here. Remember, it was a squared, so we maintain our square. So one of these a's can reduce this by 1, so that instead of what we have here, we are going to get a negative b squared all over 4a, and then plus the c. Here's what we have. Now, if we want to rewrite this nicely, then we can say we have our a into bracket x plus b over 2a all squared plus c, then minus b squared all over 4a. Once again, if you want to simplify this further, you have our a into bracket x plus b over 2a all squared. For this, we have here the LCM is 4a. So we have our 4a, then there's over 1. So 1 into 4a, how many times? 4a. 4a times c gives us a 4ac. Then we have 4a into 4a once. The 1 times negative b squared gives us a negative b squared. Now, if you are able to complete the square and rewrite your function in this form, you have actually achieved something. So what we say is, if you're able to write it in this form, then this particular b over 2a you have over here would help you get your vertex. You see, and this one as well helps you get your maximum or minimum value. So that is to say, this one here is our maximum or minimum value. And then for this particular one, if you are to take what you have in the bracket, x plus b over 2a, and you equate it to 0, you get your x being what? Negative b over 2a. If you have been following this course, you realize that we use this to determine the axis of symmetry. You see, so the axis of symmetry, and the axis of symmetry is simply the x coordinate of your maximum or minimum value, and this one gives you the y coordinate. So you can get the vertex, the axis of symmetry, and the maximum or minimum value all from this. We'll be solving 5 examples. In our examples, we will explore all these scenarios, and in our last one, which is example 5, we'll look at how to get the quadratic formula from the completing of squares. So follow me even as we start working some examples to enhance our understanding. But before that, I advise you take a minute or 2 break so that we proceed. It is very necessary. So let's look at our first question we have here. It says you have to complete the square x squared plus 10x plus 18. We have x squared plus 10x and then plus an 18. So to complete the square, we have gone through the steps already. You see, so the first thing you should do is to take note of a. In this case, we know our a is 1, our b is 10, and then our c is 18. And the step says there are 2. That is if the coefficient is 1 and if the coefficient isn't 1. This coefficient is 1. So let's go straight to the point. We find half the coefficient of x, that is the b. So half of b is simply 1 over 2 times 10. And 1 over 2 times 10 gives us what? 5. After which we square this answer we have. So 5 squared. 5 squared gives us 25. So if you are able to square it, we then add and subtract it between the second term and then the c. So that is to say, instead of our x squared plus 10x and then plus 18, we are going to rather have x squared plus 10x. We are adding and subtracting. So plus 5 squared, then minus 5 squared, and then we come to the plus 18. Now from our proofs, we have realized that always these 3 terms factorize perfectly. You see, so with that, we are going to take them out so that we have x plus 5. So we have x, and then plus 5 all squared. You see, so we ended here. Then we evaluate the remaining. So negative 5 squared gives us a negative 25. Then we have plus 18. Take note, this squared is not affecting the negative. So there's a difference. There's one mistake students often do make. Negative 5 squared is not the same as negative 5 squared. Even though they are read the same, but they mean 2 different things. This one here is actually a negative into bracket 5 times 5. But then this one here is a negative 5 times negative 5. This is what we are doing over here and not this, so that you are confused and then you say negative 5 squared also gives us 25. No. So please take note of this mistake and then try to avoid it. So with that, if you have to simplify, we have our x plus 5 all squared, then negative 25 plus 18 will then give us what? A negative 7. So we have been able to complete the square. Now, what information can we take from this? Just by looking at it, we know the vertex, we know the axis of symmetry, and we know the maximum or minimum value as well. So first of all, let's look at the axis of symmetry. For the axis of symmetry, you equate this to 0 and make x the subject. So you have x plus 5 being equal to 0. X is equal to negative 5. So if we were to plot this, this is its axis of symmetry. Now, if we have our axis of symmetry, we also know that the maximum value of y is what? Negative 7. Is it a maximum or minimum value? That is determined by the value of a. So we said if a is greater than 0, then our function has a minimum value. But if a is less than 0, then it means our function would have a maximum value because it is an n. So in this case here, a is 1, which is greater than 0. So it is going to be a u form. Hence, this is its minimum value. So it has a minimum value of -7. Now, what is the coordinate of that minimum value? It is the vertex. So the vertex is simply -5, and then you have -7. You see, so by completing the squares, we have all of this. With that said, so for our second question we have here, it says you should solve by completing the square. We should solve by completing the square. X squared minus 6x plus 5 is equal to 0. X squared minus 6x plus 5 is equal to 0. For this particular one, we have x squared then minus 6x plus 5 is equal to 0. So we have said that we check the coefficient. This coefficient is 1. So since it is 1, we can just move right away. The A is 1, B is -6, and then C is 5. The step says we should take the B and then find half of it. It simply means let's take -6 and multiply it by 1/2. 6 times 1/2 gives us a -3. Now this -3, let's then do what? Let's square it. So we square the -3 and then add and subtract it after the second term. So that simply means we have x squared minus 6x. Then this we have here, we are adding -3 all squared, and we are subtracting -3 all squared, and then plus the 5. So plus 5, and it's equal to 0. So with this, we know for these first 3 terms, we can factorize them out. So that we have x, then minus 3. So x minus 3 all squared. Then minus the -3 squared. -3 squared gives us a 9. So minus 9, then plus 5 is equal to 0. Simplifying further, we have x minus 3 all squared. Then minus 9 plus 5 gives us a -4. All that equals 0. Now it is x we want, so at this stage we start making x the subject. The first thing we can remove is this -4 here. We have x minus 3 all squared, which is equal to the negative squared moved to the other side, and we have 0 plus 4. 0 plus 4 gives us a 4. We have moved the -4 to the right hand side. The next thing we can move is the squared. So how do we remove the square? We do that by finding the square root of both sides. So the square root of both sides, this then gives us x minus 3. And then the square root of 4 gives us plus or minus 2. There are 2 values we get. We still do not have x as the subject. So to make x the subject, we'll then have to move the -3. You see, so we have our x, then our -3 moves to the other side to give us what? A +3. So let's rewrite it as plus or minus 3, plus or minus 2, that is from here, then plus 3. This is more appropriately written as 3 plus or minus 2. These are the values of x. There are 2 values. One is when we use the plus, and the other is when we use the minus. So for the plus, we have x being equal to 3 plus 2. And 3 plus 2 gives us a 5. And for the minus, we have x equals 3 minus 2. 3 minus 2 on the other hand also gives us a 1. So we can say, therefore, our x is equal to 5, or x is equal to what? 1. This is the solution to our equation using the method of completing the square. It is very simple, right? Now, there are some books that suggest that right from the first stage, since we are trying to solve for x, let's move this particular term to the right hand side. Let's try that method and see if we will get the same answer. So for that particular procedure, this is what we do. We have our x squared minus 6x plus 5, which is equal to 0. So it says let's move this to the other side so that on the left hand side we have only the x's. We have x squared minus 6x becoming equal to negative 5. Don't be tempted by factorizing out your x over here. It doesn't always work. So using the method of completing the squares, our b is still negative 6. So we find the half of negative 6, which gives us a negative 3, after which we then square the negative 3. After squaring it, this particular method says you add to both sides. So from this end here, we have x squared minus 6x. Then we'll be adding negative 3 all squared to it. And on the right hand side as well, we'll be adding. Take note, it says we should add. The reason why we are actually adding was, in actual sense, we were to add and subtract to the left hand side. But the one who would have been subtracting on the left hand side is moving across the equal to sign. That is why it becomes an addition over here. You see, so we are adding to both sides. With that, we have our x squared. Then, since we are factorizing this one, we then have our x minus 3 all squared, which is equal to, over here we have our negative 5, and then negative 3 squared gives us a 9. So we have x minus 3 all squared, which is then equal to 4. That brings us back to what we had over here, you see, and then you just continue your solution. So any of these method works. It's up to you. You master the one you think you can, and then follow it accordingly. This was question number 3. Now let's look at another example where a isn't going to be 1. You see, all that we've done so far, the value of a is 1. So let's look at the case where a is not 1. So looking at our third question we have, it says we have to complete the square 3x squared minus 12x plus 7. You have to write it in vertex form and state the vertex. So this time around, it is not equal to 0 where we'll be solving for x, but we just need to write it in the vertex form. 3x squared minus 12x plus 7. This time around, our coefficient is 3. If our coefficient is 3, then we need to bring it out. We bring the 3 out, then into bracket, we are going to divide this first term by 3. So that is 3x squared over 3. Then minus 12x over 3. We just do that for the first two. Then plus 7. So with this, you realize that if we were to revert back to the original equation, this 3 would have cancelled this 3, and this 3 would have also cancelled this 3, giving us back our 3x squared minus 12x. But we want it this way, so we have our 3, then into bracket. This 3 cancels out to this 3 to give us an x squared. We have x squared, then 3 into 12, 4. So negative 4x, then plus 7. So this is our new equation. Then we can now start solving using the method of completing the squares. So it says we should find half of the coefficient of x. We have negative 4. The half of negative 4 is negative 2. Now if we are able to get half the coefficient of x, we then do what? Square it. So we have negative 2 all squared. Then we now come and do what? Addition, and then what have you. So we have 3 into bracket x squared minus 4x. Then this we have here, we'll do what? We'll add and then subtract. You remember that? So we have plus negative 2 squared, then minus negative 2 squared. Not forgetting our plus 7. So with that, these first 3 terms are going to give us a factorized form. So that we have our 3 into bracket x. So x, then minus 2. Let me use this bracket. So x minus 2 all squared. Then we are left with this. So this one gives us a negative 4. This is the negative 2 squared. That gives us a 4. But then this negative is still unaffected. So this is what we have. Then plus 7. We now want to distribute the 3 across what we have in the bracket. So 3 times this bracket gives us 3 into bracket x minus 2 all squared. Then 3 times negative 4 gives us a negative 12. Then we have our plus 7. Simplifying further, we have 3 into bracket x minus 2 all squared. Then negative 12 plus 7. Negative 12 plus 7 gives us a negative 5. This is what we mean by it being written in the vertex form. And it says we should state the vertex. So you know, if you're able to write it in this form, there are so many things we can take from it. Even though we've not been asked. X minus 2, that is what we have in the bracket here, gives us the equation of the axis of symmetry. So our axis of symmetry is x equals what? 2. Now if x equals 2, we get our minimum and maximum value from here. Is it a minimum or it is a maximum value? Because the a is 3, then it is a minimum value. So we have a minimum value of what? Of negative 5. And then we come to the vertex. So it's the combination of these two that gives us the vertex. So our vertex is what? 2, negative 5. That becomes the vertex of this equation we have over here. Now to confirm that this is the plot of our quadratic here, this is the quadratic, and then we've written it in this form. So as you can see, we have y equals 3x minus 2 all squared minus 5. That is the final form we had over here. Now if this is its graph, you can see where we have our vertex, you see. So the vertex is just as we said. The y coordinate is what? Negative 5. And for the x, it is through 2. You see? And also, our minimum value is negative 5. And our axis of symmetry is what? X equals 2. Very simple. Now, if you relate this to what we did in our previous lesson, that is the transformations the parent function goes through. If you've not seen that, you can visit the playlist, then check the video before this. You realize that the parent function has shifted 2 steps to the right because of this negative 2 we have here. It has shifted 2 steps to the right. And then it has shifted 5 steps down because of this negative 5. And what does this 3 here do? The 3 has also compressed it. You see, it has also compressed this function. As you can see, if I'm to change the value, you see it expands. But then if I'm to increase it, the higher it value of positivity, the more it compresses, you see. But then what we had was 3. So let's maintain it as the 3. So that is it for our graphical presentation. Since we've been able to solve with the vector form, let's look at solving for x with the coefficient of x squared being what? Greater than 1, as we have done for this. This time we want to solve. Now take note that when we are solving, all we are actually doing is looking for the x-intercept. You see, so for this, for instance, if we were to solve, then this here is our x-intercept, what we have in here, where the curve touches our x-axis. That is what we do when we equate it to 0. Because at that point, the value of y is what? 0. As you can see, the value of y, instead of -1 or 1, it is 0. So our question says solve by completing the square 2x squared plus 8x minus 3 equals 0. So how do we go about it? We have our equation, which is 2x squared then plus 8x minus 3, which is equal to 0. He says we should solve by completing the squares. So what we have here, the coefficient is not 1, it is 2. Hence, we need to what? Factorize it out. In factorizing it out, when what you are working with is an equation, you see, unlike that of just the expression where we needed to write it as a vector form, if it is an equation, what you do is you divide each and every term by the 2. By so, I mean you have 2x squared, divide it by 2. You have 8x, divide it as well by 2. You have 3, divide it also by 2. And you are going to divide the 0 also by 2. You can omit that though, because you know any number, 0 over any number is still the same thing. So take note, for our left hand side here, this wasn't an equation. It was just an expression, the function. Hence, we didn't have to divide each and every term by the coefficient. But this one, on the other hand, we are looking for the roots and it has been equated to 0. That is why we divide each and every term by the 2, so as to make the coefficient 1. After our division, we have x squared plus 4x, then minus 3 over 2 is equal to 0. Then we go with our procedure. So just like the previous one, you can either take this to the right hand side, after which you do whatever you have to do with b, and then add to both sides, or you can choose to work it using the regular method. So we have x squared, and the half of 4 is 2. The square of 2 is 2 squared. So we'll be adding and subtracting, since we are doing all at the left hand side. So we have 4x, then plus 2 squared minus 2 squared, then minus 3 over 2 is equal to 0. The first 3 terms are factorized, so that we have our x, then plus 2 all squared. So x plus 2 all squared, and then we have our negative, then into brackets 2 squared gives us a negative 4. As I've explained, this is not a negative 2 squared, but it is minus then your 2 squared. And we have our minus 3 over 2, and this is all equal to 0. So now that we have this, what do? We now simplify. In simplifying, we still have our x plus 2 all squared. Then we have our negative 4 minus 3 over 2. That gives us a negative 11 over 2, and it's equal to 0. So this is where we start making x the subject. So then we have our x plus 2 all squared equals 11 over 2. We would have to find the square root of both sides. For the square root of both sides, we have x plus 2 which will then be equal to the square root of 11 over 2. You see? So the square root of 11 over 2 using a calculator is simply 2.345. So with that, we have x plus 2, which is equal to, we know since we are finding the square root, we have to use the two values. So plus or minus 2.345. Still on our x will then be equal to, we take the 3 to the other side, so that we have a negative 2 plus or minus 2.345, making our x the subject. Let's start with the positive, that of the positive. So we have x equals negative 2 plus 2.345. Hence, our x would give us a 0.35. And if you have to take the negative, we have x equals negative 2 minus 2.345. So we have our x, which is equal to what? Negative 2 times minus negative 2. We have a negative 4.345. So this is to say our x, this is our approximation. So our x is approximately 0.35, or x is simply what? Negative 4.35. And these are all to 2 decimal places. We have solved this. Now, if you want to confirm with a graph, which I would do for you, let's quickly go to the graph and see if what we have done is true. So as we can see on the left hand side, this is the graph we have worked on over here. This is how it looks like graphically. We actually wanted the solution, that is the x-intercept. So if you look here, if we are to zoom, look at where our x-intercept is. It is between 4 and then negative 4.5, but it is closer to negative 4.5. So what we have solved here, which is the negative 4.35, is actually correct. You see, if I'm to bring this close here, you see the coordinates we have there, negative 4 point what? You see that? Okay, then for the right hand side, we also have that here, which is between 0 and then 0.5, just as we work here. So 0.35. See, and if we were to also solve for the maximum or minimum value, then this would have been it over here, with this being an axis of symmetry. So that will be it for this particular question. Now, when we began, I said we would be proving the quadratic formula. That is going to be our next question. So let's quickly look into it. So our last question we have here says, derive the quadratic formula by completing the square on ax squared plus bx plus c equals 0. This here is the quadratic formula. So how do we derive it? We have our ax squared plus bx and then plus c, which is equal to 0. So we want to apply the completing of squares. I've told you if it is an equation like this and it's equal to 0, then the best thing to do is to divide each and every term by the a. So by so doing, if we divide ax squared by a, this a moves away, and we'll have x squared. If we divide bx by a, we have b over ax. If we divide c by a, we have our c over a. And then if we divide 0 by a, we would also have a 0. We are following the same process. So after dividing by a, we now have our coefficient of x squared being what? 1. So what do we do? Now, if we've been able to divide everything by a, then just as we've been doing, let's move this one, this constant term, to the right hand side, so that what we have left on the left hand side will be those that have x. With that, we have x squared plus b over ax, which is equal to negative c over a. So with that done, we now have the coefficient of x being b over a. So we find half of it. So b over a divided by 1 over 2 simply gives us a b over 2a. We then square this. So if we are to square this, we have b over 2a all squared. Now we know if we finish squaring, what do? We would add it to both sides. We are adding to both sides because it is at the left hand side and then at the right hand side. So the one we would have subtracted has gone to the right hand side. If we are to do that, then we have x squared plus b over ax, then plus b over 2a all squared is equal to, we have a negative c over a, that is from here, and then plus b over 2a all squared. So continuing from here, we have x, then we know to factorize it, we just take x and then plus b over 2a all squared is equal to, we can rewrite this as negative c over a plus b squared all over. So we know this squared affects the numerator, that is why we say b squared, and it also affects the denominator. If it affects the denominator, we have 4 then a squared. What do we mean by that? We have b over 2a and it is all squared. From the laws of indices, this is indirectly b squared over 2a all squared. From the laws of indices as well, 2a all squared is simply 2 squared a squared. That is why this is giving us the b squared over here. And then 2 squared gives us a 4. A squared also gives us an a squared. So that is where that is coming from. With that said, we can rewrite this as x plus b over 2a all squared. And then if we want to simplify this, our LCM, this is a and then this is 4a squared. So the LCM is simply 4a squared, because we already have the presence of a in this. So a divides 4a squared how many times? That is to say 4a squared divided by a. This a reduces this by 1. We'll be having 4a. So the 4a multiplies the negative c, so that we have what? 4ac. Then 4a squared divides 4a squared once. So the 1 times b squared gives us what? B squared. Here's what we have. Now, take note. The c was negative, so it maintains the negative here. Okay, it maintains the negative. So we can rewrite again so that it looks more appropriate. So we have x plus b over 2a all squared is equal to, rewriting this, let's just take b squared minus 4ac all over 4a squared. We have just rewritten the numerator. We now start our process of solving for x. To do that, we would find the square root of both sides. So if you have to find the square root of both sides, something like this, then the square root here takes out this 2, so that we'll be left with x plus b over 2a, and it's equal to the square root of this we have here, which is b squared minus 4ac all over 4a squared. Now, from the laws of indices, if you have the square root of a over the square root of b, it is simply the square root of a over the square root of b. Applying that here, then it simply means that the square root affects the numerator and it also affects the denominator. So that we have x plus b over 2a being equal to the square root of b squared minus 4ac all over the square root of 4a squared. We would continue from this line. Now, simplifying further, we have x plus b over 2a equals the square root of b squared minus 4ac. Then our focus will be to simplify the square root of 4a squared. So if we have square root of 4a squared, the square root affects both terms. So that it becomes square root of 4 times square root of a squared. Square root of 4 gives us a 2. So we have 2 times square root of a squared is simply an a. So the square root of 4a squared is 2a. DC. So we'll now rewrite the denominator we had as all over 2a. Now take note, since it is square root we are looking for, then we are going to work with two values. That is the positive and then the negative. So with that said, let's quickly bring this to the right hand side so that it becomes x is equal to, it is positive over here. If you are bringing it to the right hand side, then it becomes negative b over 2a. So negative b over 2a, we have plus or minus the square root of b squared minus 4ac, then all over 2a. There is 2a here, and there's also a 2a over here. So the LCM is simply 2a. So we have our 2a, and then there's a negative b, then the plus or minus the square root of b squared minus 4ac. As simple as that. This is the quadratic formula. So as we were given here, that is what we have proved. So this is how we prove it. And we use this to solve for x, especially when the method of factorization doesn't work. It is not always that the method of factorization works, but with this, it works for every term at all. So we then say hence proved. We'll end this lesson over here, but as usual, I'll leave with some exercises so you try on your own just to test your understanding. So here are 5 questions you can try your hands on just to test your understanding. This Hub Beyond Numbers where we learn maths the easy way. I do hope this lesson was helpful. If there's any issue of concern, you can always let me know at the comment section, and when I'm notified, I would address that for you. If this is your first time and you think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.